Greetings, everyone. Thank you to the respected chair for the warm welcome. My name is Mei-Zhen, and it is a pleasure to be here today. The title of my presentation is Transforming the Construction Industry, Evolution of Building Information Modeling Towards Modular Construction. In the next few minutes, I would like to talk about how BIM has evolved over time and how its convergence with modular construction is reshaping the way we design, deliver, and even think about buildings. Rather than looking at BIM and modular construction as separate innovations, I will focus on how they work together and why this integration matters for the future of our industry. So let's start with the context. Our industry is at a crossroads. We continue to face familiar challenges such as cost and schedule overruns, low productivity, shortages of skilled labor, and increasing pressure to deliver sustainable and high-quality projects. These issues have been discussed for years, but today, the urgency to address them is greater than ever. This situation calls for more than small improvements. It calls for a fundamental change in how we build. This transformation begins with a digital foundation, Building Information Modeling, or BIM. BIM has evolved significantly from its early days. We moved from traditional 1D and 2D drawings, which were often fragmented and difficult to coordinate, to 3D models that improved visualization and interdisciplinary coordination. Today, BIM has expanded into multiple dimensions. We now integrate time through 4D, cost through 5D, sustainability through 6D, and facility management through 7D. What's important here is that BIM is no longer just about producing drawings or models. It has become a collaborative process that manages reliable information across the entire life cycle of a building, from early design decisions to operation and maintenance. So what is the real value of BIM? At its core, BIM enables data-driven decision-making. Instead of reacting to problems on-site, teams can identify and resolve issues digitally much earlier in the process. For example, clashes between systems can be detected before construction begins. Quantities can be extracted accurately for cost planning. Construction sequences can be simulated to assess risk and logistics. In many ways, BIM allows us to carry out a digital rehearsal of the project. This reduces uncertainty, improves collaboration, and gives projects a much higher level of predictability. And this idea of predictability becomes very important when we start to move work offsite. This brings us to modular construction. Here, we shift significant portions of construction from a complex, weather-dependent site to a controlled factory environment. Building components or entire modules are produced off-site and then assembled on-site. The benefits include faster delivery, improved quality, better safety, and reduced waste. The key point here is that BIM and modular construction are not separate trends. BIM is the essential enabler of modular construction. the level of accuracy and coordination required simply cannot be achieved without a strong BIM process. BIM provides the information needed by both the factory and the site team. So now, let's take a moment to look at how this integration works in practice. Everything starts with the BIM model, which is developed with manufacturing and assembly in mind from the very beginning. Design decisions are made based on how components will be produced, transported, and installed, not just how they look on paper. This model then fits directly into manufacturing drawings and automated production systems in the factory. At the same time, it supports logistic plannings, such as delivery sequencing and site constraints. On site, the same BIM data guides installation and assembly, sometimes supported by technologies like augmented reality to improve accuracy. What we get is a continuous digital thread from design to factory to site, minimizing information lost and rework. The outcomes of this approach are tangible. Projects using BIM-enabled modular construction report significant reductions in time and cost, improved quality, and much safer site conditions. For example, modular residential projects can be assembled rapidly using factory-produced units, cutting months off the construction schedule. Of course, adopting this approach is not without challenges. It requires early commitment and close collaboration from all project stakeholders. It also involves changes to traditional procurement methods, contracts, and supply chains. However, the future direction is very promising. We are moving toward an integrated digital delivery environment where BIM models are connected to digital twins, IoT sensors, and real-time performance data. This allows buildings to be monitored, optimized, and managed throughout their entire life cycle. In this context, construction is no longer just about assembling materials on site. It becomes the manufacturer of integrated building systems. To conclude, the evolution of BIM is not an end in itself. BIM acts as a digital catalyst that unlocks the full potential of modular construction. When these two approaches are combined, they offer a practical solution to many of the long-standing challenges in our industry. Together, they enable higher productivity, better quality, improved sustainability, and greater certainty in project delivery. This convergence represents a fundamental shift from traditional construction practices toward a more manufacturing-oriented and data-driven model. The future of construction is not just digital, and it is not just off-site. It is intelligently integrated. Thank you very much for your attention. I am happy to take your questions.